The galaxy we call the Milky Way.
Thank you again. It's great to be here, and I want to welcome those of you who were here last night. And yay! And those who weren't here last night, boo! No, this is a wonderful weekend for us at the Origins Project, and tonight is going to be a great night, and I'm very excited about it. I want to repeat one thing I did say last night for those who weren't here. For me, and for all of us, it is a true privilege to be located in a place, this place, where we can fill up 3,000-seat auditorium for science. It says great things. It's true. It says great things for all of you, and we really appreciate it. But tonight is an amazing evening because without hyperbole, it is true that I don't think there has ever been on one stage an assembly of science storytellers and communicators like this. It's very intimidating, in fact. I have had the good fortune, I realize, to appear on stage with each one of these people individually, but all together. It's going to be an amazing night. And the way it's going to work, when you got great jazz musicians, you allow them to jam. And so the way we're going to do it is we're going to bring everyone out in a minute or two, and everyone's going to tell a little science story for you, to give you a sense of what excites them about science or to how they interpret science. And each one of the people will do that, and that should take a while. And then we'll take a break. Then we'll come back, and we're going to have a discussion. Then we're going to open it up to all of you. I believe you have question cards. If you want to write down your question by the intermission, bring them down, and then we'll choose some questions. And after we have our discussion, we'll try and answer your questions. So that's the way it's going to go. So I want to introduce each of the panelists in order. The first person that I want to introduce is the director of a remarkable festival, which is, I would say, next to the Origins Project, the most amazing science festival in the country, the World Science Festival in New York City, and I've been privileged to be part of it 4 or 5 times. And Treisy Day is the CEO of that, a former broadcast journalist, and puts together this remarkable program of 30 to 40 different science events throughout New York, and with lots of different scientists and musicians, and it's an amazing event, and it's been a privilege for me to be a part of it. So I want to bring out Treisy Day first. Thanks, Treisy. Thank you. Next, I want to bring out an old friend of mine and one of the most well-known physicists in the country. He burst like a supernova on the stage of the public stage with his first book, The Elegant Universe. And I think of him as a long-lost son, really. And Brian and I have been together in many venues, and he is really one of the most remarkable and vibrant communicators of physics, particularly particle physics, in the country. And it's really a pleasure to welcome him back to the stage today. Brian? Papa! Okay, enough. That love, I feel it. Thanks, Brian. I'm not turning my back to you, I think. But the next person I want to bring on stage is another old friend, and I've been privileged to be on his program a number of times. And he is really one of the most amazing, well, he has the most amazing radio program in the country about science. But if you've been on the program and you've experienced it, you can see what an amazing job he does in interviewing people. Brian and I and Ian McEwen were on earlier this week, and when you're on there, you see the incredible talent. And I know that when I try and moderate these panels, what I think is I'm trying to channel Ira Flato. And so I'm happy to bring out Ira Flato.
Thank you.
Yeah, it's okay. Next, I want to bring out a little guy who is now everywhere. He's on TV. He's about to make a new series, a remake of the Cosmos series. And he's the director of the Hayden Planetarium, and in fact, I was privileged enough to be there last week for an event that he moderated. And now I'm going to return that favor to him and not let him talk either. He's a little shy, but I think we can encourage him to come out. Neil deGrasse Tyson. You're over there. Oh, hold on.
No,
you're not over there. You're over there. Sorry. Yeah. It's okay. Next, we have, as I said last night, in my own mind, the person we all look up to as one of the greatest writers about science in the history of science, and someone who changed the way science writing is done and communication is done with his book, A Selfish Gene, which was published almost 40 years ago. And it's a surprise guest because he wasn't in the original program, but he was here last night, and we'd be remiss if we didn't include in this program Richard Dawkins. That's great. Now, the next guy is a real guy. In fact, he's a science guy. And I don't think I have to say anything else. Bill Nye has been an amazing educator on television. I love watching him in Disney World each time I go to Epcot Center. And he's been a pleasure to interact with. He's also the executive director of the Planetary Society, which is a position that Carl Sagan first had. And it is truly a pleasure and a privilege to welcome to the stage Bill Nye. Thank you. You take care of that. An amazing group. And the last person I want to welcome to the stage is a little bit different, but in fact, he communicates science in a different way. In my mind, personally, I think he is the best science fiction writer writing today. He is incredibly prolific. I don't know how he produces what he produces. And I've been with him in a number of events, and he has an incredible following. He weaves science in his stories in a way that very few science fiction writers really do effectively. And it's truly, again, a privilege to welcome Neal Stephenson to the stage. Thank you. Okay, so we're going to begin. If we go to the first slide, actually. And as all of my colleagues will point out to you, it's always about me. And so the story, I want to tell you a little science story, and it's a story about me. In a way, it's a story about what got me interested in science, because I thought that would be appropriate. This person here is Richard Feynman. This young person here is me. And Richard Feynman made me want to be a scientist for a number of reasons. When I was a high school student, I took a special summer program, and I was bored. And the teacher came down and said, "You look bored," and he gave me a book. And in fact, I think if this works, it does. This was the book. It's called The Character of Physical Law by Richard Feynman. And he said, look, this is a book by a guy who won the Nobel Prize recently for proving that antiparticles are particles going backwards in time. Wow, this is amazing. So I took the book home, and I read the chapter. I didn't understand any of it. But it was really neat. But the thing that was important for me, and I hope one of the things I like to tell students, because we tend to teach science, as I said the other night, as if it's done by dead white men. And when I looked at this, I realized, not all the problems are solved. There's still an incredible number of things we need to understand about the universe. And it was the first time that I thought a career in physics might actually be worthwhile. There were things left to discover, that all the great things hadn't been known. And it changed my life completely. Now, like all good physics undergraduates, I'm sure Brian and Neil at very least, I carried around with me the Feynman lectures on physics. He rewrote all of introductory physics in his own style. He was incredibly charismatic and an amazing teacher. And I carried them around. Again, I couldn't understand them. But I thought by osmosis, if I carried them around long enough. It was only when I was a graduate student that I really began to appreciate the depth of those descriptions. And that kind of, as I thought of being an educator, the idea, what was amazing about Feynman was that he conveyed his excitement and his interest and the integrity of science, as I'll talk about in a second. Now, I was lucky enough, as it turned out, when I was an undergraduate, to meet Feynman at a meeting up in Canada. And this was actually taken in for a physics magazine. And I'm pleased we were actually talking physics at that instant. But I spent most of the weekend with him because I brought my girlfriend at the time, and she was one of the few women. And Feynman, if you knew anything about Feynman, he decided to spend most of his time with us. And besides actually teaching me how to dance, he convinced me we had long talks about adventure and seeking out adventure. And I know for him, science was an adventure, and it is for me, but it was everything in life was an adventure. Learning, just the pleasure of finding things out, as he wrote. And that became infectious for me and changed and invigorated me to become a scientist. Now, it turned out many years later, when I was at Harvard, I gave a colloquium at Caltech, where Feynman was teaching. And it was very intimidating, of course, but he asked a good question. Then he came up afterwards to talk to me. And I really wanted to remind him. I was certain he wouldn't remember our weekend together. And he wanted to ask me a question, but there was a very annoying assistant professor who would not stop asking me questions. I'm very happy to say he didn't get tenure. But Feynman walked off, and I thought, well, I'll catch him later. But he died shortly afterwards, so I never was able to tell him what he meant to me. And as a result, I wrote a whole book about Richard Feynman, because for me, he captured the way science is done. I'm going to let him tell you in the last minute his own story, or at least the way he saw science. But I want to tell you one of the facts about science, the kind of things that would amaze him and amaze me. All of you take a breath. Hold it in. I can't see. Are you still holding? No, you can let it out now. Okay, good. Well, there's a possibility, in fact, a likely possibility, that with every breath you take, you are breathing in atoms that Richard Feynman breathed out when he gave the interview I'm about to show you. And every time I'm sitting at my desk, not getting anything done, feeling ignorant and incompetent, I like to think that I'm breathing in atoms from Richard Feynman. And that sense of joy and mystery, to me, is what science is all about. And no one conveyed it better than Feynman, and so I'll let him finish this off in his own words.
You see, one thing is I can live with doubt and uncertainty and not knowing. I think it's much more interesting to live not knowing than to have answers which might be wrong. I have approximate answers and possible beliefs and different degrees of certainty about different things, but I'm not absolutely sure of anything. And then many things I don't know anything about, such as whether it means anything to ask why we're here and what the question might mean. I might think about it a little bit. If I can't figure it out, then I go to something else. But I don't have to know an answer. I don't feel frightened by not knowing things, by being lost in the mysterious universe without having any purpose, which is the way it really is as far as I can tell, possibly. It doesn't frighten me.
He wasn't frightened, and he loved mysteries, and that's what science is all about, to me. Thanks. Tracy, you want to go up next?
I would love to. Am I supposed to stand?
Yeah, you can go stand. You can do whatever you want.
One thing is probably obvious, which is I'm quite different from others on the stage. Actually, I'm quite different in another way. I'm neither a scientist nor a science journalist. And honestly, if my former friends and colleagues, my friends and colleagues saw me on this stage with this group of people, they would laugh because I was actually a broadcast journalist and I covered wars, I covered politics, I covered many things, but I never covered science. And that is because we all assumed that science was boring and that scientists were boring. And so my story is really about how I discovered that science is a great story. And I did a program in about 1999 called The Century with Peter Jennings, and I was producing a part of it called The Thinkers, and I interviewed many impressive, incredible people. And what I found that the scientists were actually more interesting and more compelling than anyone else I talked to. Actually, there were Richard Dawkins, Brian Greene, many others were in that program. And so I realized again that the science stories are really, they were untapped. They were, people didn't realize in the mainstream media that these are great adventure stories and many other things. So in 2005 or so, Brian Greene and I co-founded a thing called the World Science Festival, and what we wanted to do was bring science to a general audience in a very new way. We wanted to use all of the storytelling multimedia techniques you could throw at these great stories. And the key thing is we wanted to put the scientists on the stage. They were great communicators, and they often didn't get the chance to do that. So Lawrence is a wonderful participant in the festival. He has been there a number of years. And so he asked me to, as part of this talk, bring a video that would actually show what the World Science Festival is and does. So if we can bring the lights down, we can show a bit of that.
Some of the biggest names in science and the arts have gathered here in New York City for the World Science Festival.
The festival, which has been called a new cultural institution by the New York Times, takes science out of the laboratory and into the streets.
World Science Festival kicks off with a star-studded gala performance hosted by Oscar-winning actor Alan Alda.
Tonight we fly across the cosmos at the speed of art. Scientists and artists come together and give us a view of nature that is both fascinating and fun.
It is my distinct pleasure to dedicate Icarus at the Edge of Time to tonight's honoree. More than any other member of our species, Professor Hawking has traveled closest to the edge of time.
I am very honored by this wonderful evening.
What's such a great adventure about science?
The idea that we can all understand science and not have to be scientists is just a wonderful miracle of this festival.
There's a tremendous appetite in the public for knowing what science is actually accomplishing.
Is life a one-off chance?
Are our genes our destiny?
Is there a mathematical order to nature?
What the hell is mathematics?
Is there aliens in space?
This is what science is about. The excitement, the wonder, the adventure, the discovery.
If you ask me what do I hope to find, I don't know, more cool stuff.
To moderate this panel on quantum physics, do you know anything about it?
Well, you know.
The most intimidating audience to teach a short Black Holes 101 course in front of Professor Stephen Hawking.
Give us a thumbnail sketch of the beginning of the cosmos as we now know it.
You can actually do a calculation to find out how many bits are necessary to simulate the universe.
The program here tonight will discuss more dimensions
than meet the eye.
Now, string theory, it's multi-dimensional, vibrating strings that are so small that there's no way to ever measure at any imaginable point in the future. And yet, people still take you seriously.
Kinds of things that will be said here on this stage this evening are the kinds of things over which wars have been started.
There's no animal in the animal kingdom has wreaked the kind of havoc that we have.
Unless we take care of the ocean, nothing else really matters.
You deserve to be punished for doing the wrong thing.
Tonight we're going to explore science and religion. Why do you still have faith in God?
What do you mean still?
You can't predict what's coming next. You can't prove what's coming next. I'll tell you what. You don't care because you're a physicist. If you can't solve a problem, convince yourself that it's not important. Forget about it.
We got to get especially young people interested in science, because by the time they hit school, it is literally crushed out of them.
I think young people care a lot more about science than we did when we were their age.
Who among the young people here would like to go to Mars?
What can people expect from a free street fair?
You won't find falafel or tube socks. This is really wall-to-wall science.
I love the idea that they're taking the exhibits out to the people.
I live for being around great young scientists because the world has amazing possibilities.
I am a mathemagician. That's 300 times 238 plus 31 squared, 71,400 plus 961 is 72,361. Let's hear it for algebra!
Is something beautiful to you because we're hardwired to like beautiful things, or because it relates to reality?
Put your stereo glasses on.
These images, they are artworks of the universe.
The storytelling has to be direct enough to move us from one panel to another panel to another panel.
Science Festival. I'll be there.
So as you can tell from that highlights reel, what we try to do is open up new avenues of entry into science through the arts, through debate, discussion, through Nobel laureates talking to children, and what we hope to accomplish. And based on the people who attend, I mean, it's been 5 years, and nearly 1 million people have attended the live events. And the goal, and what we hope will continue, is to move science out of the siloed existence that it tended to be for a general audience and smack into the middle of popular culture where it belongs. So, thank you.
Thank you, Tristan. Okay, let me call upon your trailing spouse.
That's right.
Brian.
Thank you. Thank you. So, as I suspect most of you know, you are a very unusual audience, an unusual group that would come out in this enthusiastic way in support of science. I mean, most of the world doesn't see science in that way. Most of the world doesn't see science as a story, right? Most of the world sees science as this collection of facts that they were forced to learn at some point in school and then spit it back on an exam, and they were all too happy to leave it behind after the exam was over. But of course, what could be more human than science, right? Science is about asking questions and observing, exploring the world to try to find the answers. And that's what we do, right? That's what we do since we are even little kids, right? There's so many stories that get that across, but let me just give you one to get things going. So, you know, my son, he's somewhere out here. He's 8 years old, somewhere out there. There he is, right there, yeah, good. Thank you. So when he was about 4.5 years old, I was telling him a lot of bedtime stories, and I was really trying to put some science into the stories, right? You know, so I'd have all these spaceships flying through the universe, but I was always very diligent in saying, they weren't going faster than the speed of light. One night, my son turns back to me and says, "Dad, speed of light? What about the speed of dark?" And it's like a thought I hadn't really had before. But you see, a young mind grappling with these kinds of ideas takes it to an unusual place. And just to be an equal opportunity parent, my daughter's also out there. And yeah, thank you, Sophia. Good, good, good. And, you know, I have, for the last few years, been thinking about ideas that are unfamiliar to most people, the possibility of other universes, the multiverse. I mean, you know, most of us were raised to think universe means everything to begin with, so how could there be other universes? And I say most of us with some forethought because, you know, my kids have heard me talk about this stuff all the time since they were really young. And Sophia, when she was 3.5, I was holding her one day, I said, "Sophia, I love you more than anything in the universe." And she turned back to me and said, "Dad, universe or multiverse?" Now that's how we begin, right? We have these open minds trying to understand everything in the world around us. But as we get older, right, we begin to deal with uncertainty. Like what Feynman was saying, how do you deal with a universe that you don't really understand? How do you deal with cutting-edge ideas that you don't even know if they're right or wrong because they're at the forefront and we haven't been able to test them yet? And I got a taste of how different people deal with that when I wrote The Elegant Universe back in 1999. It came out, you know, it appeared on Amazon, and as you all know, you know, Amazon is this wonderfully democratic approach where anybody can write a review of a book that they've read or haven't read. So a few days after the book appeared, you know, somebody wrote in and gave it 5 stars. I was happy, that was good. And then I read the review and they said they were so happy that someone finally had written a book on string theory that was accessible because they said it's so hard to criticize things you don't understand. And they went on to say that after reading the book, they felt string theory was a bunch of mathematical buffoons chasing their own tails, and finished by saying that the reviewer felt that the author, namely me, seemed to be about as happy as a pig in shit. And what the reviewer was trying to say is, when you don't know if ideas are right or wrong, as it is with some of these cutting ideas about string theory and other things, there can be a deep level of uncertainty. And how do you deal with it? Feynman found it invigorating. Others find it deeply uncomfortable. And that is a wonderful divide in terms of how one goes about exploring the universe. Okay, now for my story. In my final 2 minutes. I got 2 minutes left, right? Okay. So one quick story, a kind of personal story, not that personal a story, but a story about discovery. I mean, what we scientists live for are the rare moments when it all works, right? We're doing a calculation and it all comes together. And this example is one that comes from a 1990s, 1992 or so. I was at the Institute for Advanced Study at Princeton. And I was working with a couple colleagues, Dave Morrison, who's normally at Duke at that time, Paul Aspinwall, who's now at Duke as well. And we wondered whether in string theory the universe might evolve in different ways than it could in Einstein's general theory of relativity. Right? In general relativity, we all know that space can stretch, it can expand, it can twist, it can warp. But one thing that can't happen in Einstein's general relativity is space can't tear apart and, say, repair itself. That tearing process would yield to physical phenomenon that would be disastrous, and the mathematics doesn't allow it to happen. We asked whether in string theory space might actually rip. So we broke this problem into 2 parts. Dave Morrison and I tried to work out the mathematical calculation that would give us insight into whether or not this tearing process could happen. Paul Aspinwall was working on the computer code that was going to implement these mathematical ideas and do the final calculation to see whether it was possible. And we phrased the calculation in terms of a physical parameter. You can think of it as the mass of a particle. We asked ourselves, if space ripped, would the mass of that particle smoothly change, or would it abruptly change in a way that would establish that that process was discontinuous, couldn't happen? So Morrison and I, we spent months working out the mathematics that needed to be plugged into the computer program. Paul had finished the program, was waiting for our results. It was a Friday night in the Institute for Advanced Study, quiet, right? It's a very quiet place at night. And we finished up, and we wanted to put it into the computer program. So Paul, who'd already gone home, he called him up and said, Paul, can you come back? You know, we finally got it. We can put it in, and we can hit the button and see whether this happens. And Paul said no. It was Friday night, he wanted to watch TV, and he wasn't going to come in. He said it can wait until Monday. So we said, Paul, will you come tomorrow morning? He said, look, the only way I'm going to come tomorrow morning is if you buy me a six-pack of beer, and it's waiting there for me. We said, okay, it will be waiting. So he came in the next morning, put in our result into his computer program. We all huddled around the terminal, and Morrison hit the enter button. And what we were looking for, what we boiled it down to, is if it came out, it sort of sounds like Douglas Adams, so it's not, if the number 12 popped out, this is real. If the number 12 popped out of this computer calculation, it meant that space could tear in string theory. So we huddled around, he hit enter, and instead the number popped out was 3.99999. And we're like, oh God, it didn't work. But wait, we said 3.999. It's so close to a whole number. Maybe it's just a round off error. Remember, it's really 4. And maybe we just lost a factor of 3 somewhere in the calculation. So we go back to the calculation, we put it up on the board. Lo and behold, we find the missing factor of 3. We put it back in, hit the enter button again, and out it comes 11.999999. That's the round off to 12, and it worked. And at that moment, I just ran around the office because we were looking at something that nobody else had seen before. We were looking at evidence that if string theory is correct, that space could tear apart and repair itself in a way that Einstein's ideas would not allow. It was this thrilling moment to look at this new phenomenon coming out of this research, and that is really what science is about. It's those moments where you're looking at reality and you're peeling away a layer that nobody else has been able to peel away before. And it's my strong feeling that we scientists, look, we have those moments rarely, a few times in a career maybe. But if kids could even have a small glimpse of that, even by solving problems that we know already have answers, but that moment of going from confusion to clarity, that transition is what science is, and that's what makes it exciting. And if only more kids would have that experience, I just think it would change the world. Thank you very much.
Now you know why I'm so proud of my boy.